Hey friends, welcome to the Adventures of Blink. I am of course Blink and I am so glad you've joined me today. Make sure you like, subscribe, and click that notification bell so that we'll stay connected. And you can of course drop by the blog at any time for more content as well. Now last week, we added levels to our game. We have the ability to create them in text files, load them, and play them. But what happens when we win? Today we're going to build a win screen. A place where you can get to only by completing all the levels. Let's go on ahead and get started. Okay, so let's build our win screen. It's pretty much the same as the other screens we've built, but we'll just kind of walk through it to refresh, right? So the first thing we're going to do is import Pygame. We're going to need Pygame to be able to access some of the features like rectangles and font text boxes and things like that. So we'll need Pygame, and then we're going to create a class that we're going to call WinScreen. Okay, and the WinScreen class, of course, has a constructor. Just like the constructors of the other ones, we're passing in the screen object and the config object. And let's see, so self.screen equals screen. We'll go on ahead and set these variables as members of the class so that they're accessible as we need them. Self.config equals config. Now the class has both of those present. They can be accessed from any method. We'll do self.bg color. So we're going to do a background color for the screen. And this is going to work just like it does in the other ones, where we're going to do, we're going to use the same color scheme as whatever's on the menu right now, just so we don't have to build a bunch of new variables. You could, of course, customize this and make it, a completely different approach. But I like when things are sort of standardized across the environment. So this way, if we ever change the menu screen, it will also change the win screen to have different, or that same color scheme applied. So we're going to go get the BG color variable. And if we don't happen to have that in our config file, we'll just use zeros, so black. Self.text color. And I'm going to do basically the same thing, except I'm going to get a different value here. We'll get text underscore color from our config file. Then we'll do raw font size. You'll notice this is not a class level variable. It's just for the constructor. This isn't something that we're storing and passing around, because we're effectively just printing something on the screen and waiting for the user to click a button. So the raw font size will do the same config thing, except we're going to grab the font size variable from within the menu. And if we don't have one, that of course is not an array, so we'll just use 60. Then we'll do self.font size equals raw font size if is instance raw font size int else 60. Now, do you remember why we did that? That's about being defensive. So the idea is that it's possible somebody could miscalculate things in the config file and put in a value that's a string, or they could put in a value that's an array of things or a tuple. And we want to be able to protect ourselves against trying to use that value unless it's what we expect it to be. So in the case of this, we want it to be an integer. Self.font is the next thing we're going to do, and we're going to create a pygame.font object. And for that, you know what, this is another config thing, so I'm going to pass that in, and we're going to get from the menu, we're going to get the font. And if we don't have anything there, we're going to do assets, fonts, blocks 2. Okay, and then after you've pulled the font, you have to use the font size as part of the font creation. So there we go. That's all we really need to have on the screen. We're just going to put up a big message that says, hey, you won, or whatever, right? So self.screen_width equals, and we'll get the screen width variable. Oops, editor's helping me out there. Screen width variable. And if we don't have it, we're going to assume it's 800. And then we'll do the same thing for the screen height. So I will pull that out and do screen height. And I believe we're using 800s for both of those. Yeah, we'll do that. Okay. Now, self.menu items. So this is drawing on the way that we did the menu. We created a list of menu items that would be displayed. We're going to follow the same pattern here just in case we ever needed to come back along the way and create new things. We're only going to have one item at first, but this at least sets us up for later. If we ever have to expand, we're already sort of pre-positioned to do so. So we're going to put a label and click to continue is our action, or click to continue is our label, I'm sorry. And then we're going to do action equals take us to the menu. Okay. Now we're going to do self.buttons, and that'll be an empty array. And we're going to do self.setUpButtons. Okay, so I'm following the same pattern as in my menu class. Remember the way we did it there. We have a setup buttons. And the interesting thing about this is we're setting up buttons as if they're going to be useful, but we're actually not using them as buttons. So we're just kind of doing, here's your start Y equals 200, and your padding equals 75. These are kind of just default values that we're throwing in here. We could be a lot more flexible with this, and in the future we might need to be, which is why I'm leaving it in here this way. But out of the gate, this probably is a little bit of overkill. So we're going to do for I, comma, item in enumerate self.menu items. So we're going to go get the menu items out of our array that was just up the way here a little bit. So we're going to go get each one of these, and in this case there's only one, so it's a for loop that executes one time. Like I said, I know it's overkill, but the idea is to position myself later if I want to modify this page to be more interesting or to have other stuff on it. I want to sort of be prepared for that and have some flexibility later. So let's see, I'm going to do text_surface equals self.font.render, and I'm going to render the item label. And I need a true there for anti-aliasing. And then I'm going to do self.text_color. Okay, so that should be the text surface. So we're now going to render the font to display the label text from our item. Then we're going to create a rectangle, text surface dot get rectangle. And we're going to set the center equals the screen width divided by 2, and start y plus I times padding. All right, so that way, if we have multiple lines in the future, they will all render just one line after the other, and there will be a little padding in between the lines, so that we print things out neatly. Again, third time I've now said it, right? This is all overkill because we're not expecting to have multiple lines on this page, at least not in today's episode. But later on, this gives you the flexibility to do cool stuff with it very easily. So self.buttons.append, we're going to append our rectangle and its action and its label. And I need to close the, oh, did I miss something here? Just a second. So open the, oh, I closed the curly too early. Got ahead of myself. There we go. All right. Okay, so that's everything for setting up the buttons. Let's go on ahead and create our draw method next. So we're going to define draw. And let's see here, we'll do self.screen.fill, because the first thing we want to do is blank everything out. So we're going to do self.bgcolor, and now we've made a black screen, or whatever color screen if you've changed yours around. The next thing we're going to do is draw the title. So we'll do title font, and that equals pygame.font.font self.config.get menu, and if we don't have menu, then a blank .get font, and if we don't have a font, we'll load it in directly as this. Self.font size plus 20. So remember, we captured the font size of the smaller text. We're putting a title up above it. So the buttons are all stacked in a row, but we're going to put a title above it that also is a little bit larger. All right, so after doing that, we need a title surface. Congratulations, you win. Good message. True for anti-aliasing. Self.textcolor. And now we need a title rectangle. And we're going to put the title also centered on the screen. So we're going to say the center of this should be at screen width divided by 2. And in this case, we're going to come down just 100. Self.screen.blit. And we'll put in the title surface, and the title rectangle. Okay, so now that we've drawn the title, let's draw the buttons. These will go a little bit quicker. So for btn in self.buttons. We're going to go through each of those button objects that we created, and we're going to make a text surface. And we're just going to render the font because the font was already created for us. We created that up above. So all we have to do is a self font render, and we go get the button label because that's the text we're going to put in it. And we're going to do true self.textColor. Then we're going to do self.screen.blit and put in the text surface. Oops, I meant to autocomplete that. And btn rectangle. So we're going to go get the rectangle from our previously created button object. Okay, now that we've done that, we should be ready to do a pygame.display.flip. We've now rendered all of our new elements, and it's time to flip the screen to the next frame. All right, now the last thing we need to put in our class is a run method. Remember that every one of our screens takes control from the previous screen, whatever called it. And so when we get here, we need a run method, which is going to be the infinite loop where we live until we manually break ourselves out of it. So define run, not ren, self. Okay, and as I said, this is going to be an infinite loop. So we're going to do while true for event in pygame.event.get. So if they happen to click the little X to close the program, the quit button, then we want to honor that. So we'll do event.type equals pygame.quit, and we'll return quit. And that's all good. But what we really want is for this screen to just stay up until they click the mouse button. In fact, we put that in if you look back at the label that we put on the buttons, it says click to continue. So that's what we're shooting for, is the idea that we want them to click the screen when they're ready to leave the windscreen. So if the event type is pygame.mouse button down, if event.button equals 1, so that's a left click, then return menu. Okay, and now we're still inside of our infinite while loop, so we check for the events we want, and then we do self.draw. All right, and that will be a working windscreen. Now that we've built our windscreen, let's make it appear when the game is completed. What does that mean exactly? So in order to plug our windscreen into the rest of the program, we need to figure out where it's going to live. And the place it should live is, of course, right after we've played the game. So let's go look in our main py and see if we can figure out how this works. On the main screen, let's go down to defining main. Okay, we're looking here. You know what? I'll expand this a little bit. We don't need quite so much terminal. So we open up the game and we go into the cycle of playing. And so while we're playing the game, let's see, we've selected new game. So we've played the game right here. Now, what we're going to do is something a little different. We need to capture the response from this. We've sort of ignored it, but if you remember on play game screen, we actually do send a response back. It's just that it never mattered before. But now that we're playing the game, we're expecting to see that response come back from the win or from the game that says you won. So we're going to put a response variable here, and that's going to capture that. And then the next thing we're going to do is check if the response contains win. And if it does, we're going to show the win screen. Now you see there's a squiggle on that because we've never actually written the show win screen method. We need to go back up here, back up to the top of this thing a little ways, and let's go on ahead and write it. So we'll put it right in here after the play game screen. We'll do show win screen. And we pass in a screen and a config. All right, and so we're going to do win equals win screen. And we know we passed the screen and the config into that. You can kind of see this is going to follow the same pattern as all the other screen creations. But it's helpful to kind of walk through this again. We're going to get the response from win.run because that's going to tell us, what's happened within the win game or within the win screen. Okay, and we'll return response. Okay, now we also don't have win screen defined, so we're going to need to go up to the very top of our method here or our class here, and we're going to put from screens.winScreen import winScreen. All right, so now we've handled everything at the main level. Like that's where it plugs in. But we're still missing an element. And that element is the game doesn't know that we've won yet. We have to tell it when that has occurred. So how are we going to do that? We need to go into our game window. Okay? And we're going to go actually almost to the very bottom of the method or of the class. So in the game window class, we currently have a check for if not self.bricks, right? And if not self.bricks means you've completed this level. Now, if we've completed the level, that's cool. But what we really want to know for the win screen is, have we completed all of our levels? And so we're going to need a way to approach this that tells us whether we've won the game or not. And it's going to be kind of fun because we're just going to add this to the bottom. And we're going to say if self.bricks equals, or not equals, is none. Then we're going to do self.logger.debug and say no new level found. Win game condition met. Okay, so the idea here is that we know if we reach the end of a level, the bricks object is empty. And so if it's empty, we know we've completed it and we're ready to load the next one. But if we load the next one and it doesn't actually exist, then we've now loaded all the levels. And if we've loaded all the levels, then we need to be able to address that. Like that's what means that the game is won. So if self.bricks after loading a level is still none, then that's why we're going to do this. We're going to say no new level found, win game condition met. All right. Now what happens at the moment we're ready to do that? Well, remember that we're in a place where the mouse has been made invisible. So the mouse was, the visibility was turned off of the pointer so that we would just be moving the paddle. So the first thing we're going to do is actually tell Pygame to give us our mouse pointer back. We're going to do mouse.set visible true. And then the only other thing to do is return win from this location. because when return win fires, that sends that back to main.py. And in main.py, we just said if it comes back with win, then you display the win screen. So we're taken care of. Okay, so we should be good, right? Okay, but we're still not technically done, because our condition here to go to the win screen is that self.bricks has to be none. Well, let's go take a look at our level file, and I think you'll see something interesting here. Level returns a list of rectangles. Okay, if a list is empty in Python, it does not equal none. So we have a problem there. We're sending back an empty list, not a none. The none is like a null variable. It means there's absolutely nothing in this, not even like a list structure that has nothing inside it. It's actually completely empty. And so we have to change the way our level loader works in order to address that problem. So here's how we're going to do that. Up at the top of load level, we're going to make an extra check. And so right before we do the file, we need to know if the file actually exists. Because remember, the way that we handled the levels was we did like level-1, level-2, level-3. And so we kept track of the counter to know what level we were on. And we could keep loading levels indefinitely as long as we had text files for them. But one thing we're missing here is that if that level doesn't exist, then we don't have any indication that we've fallen off the end of our list. And so we need to check whether that file actually exists before we try to open it. So we'll do if not self.levelFile.exists. Oops, missed my colon there. Then we're going to print. We're not going to print. We're going to do self.logger.debug. Or no, wait. We can do a warn here, right? Or warning, sorry. So we'll use the actual warning layer to say oh, and you know what? I needed to make this an F string. There we go. So we're going to just say, hey, the file was not found, so we can't load it. Now that might actually be good behavior, because what we're going to do with it is return none. So if we got there accidentally, if we're troubleshooting something and it's not behaving the way we expect, we get a warning message that says, hey, this might not be the way you wanted it to behave. But we're calling this the win condition because we've tried to now load a level that doesn't exist, which means we've reached higher than our database has in it. Our folder doesn't have any more levels to give us. So we'll just return none and call it even. Okay, so now we should be able to test this. In order to test, we're going to make a level 1, which just has 5 bricks in it. We're going to make this really fast, right? And then a level 2, and I'm going to do the same thing. Actually, you know what we'll do is we'll copy everything from level 1 into level 2 for the moment. All right, and so these should be really fast for us to play through. Let's go on ahead and do it. Python source.main.py. I'm not in my virtual environment. I had a system update between last week's episode and this one, and it kicked me out of my virtual environment. So source.venv bin activate, and now run that. Oops, I missed a colon someplace. Let's go see. Of course I did, at the end of my for loop. There we go. All right, so now let's play our game. Oh, There we go. It's flying. 4, 5. Okay, that was level 1. Now we're playing level 2. And level 2 is completed. Ooh, and our graphic is a little off. We'll have to fix that. All right, so a little movie magic. I think I went and figured out what I did wrong. The problem actually comes in back up here where we define the screen width and the screen height. I got in a hurry and I was using menu.screenWidth. But if we go look in the app config, we'll see that menu does not have a screen width. So it was using the default values, which is why everything looked skewed. What I actually needed to use was app.screenWidth. So if I come back to my windscreen and I change this to app screen width and screen height, now I should be able to see everything work perfectly, assuming I can beat my game again. There we go. And now our windscreen looks appropriate. Pretty cool, huh? We made a special winning screen and detected the wind condition. Let's go on ahead and push up our changes for the day. All right, so we're going to come in here and we're going to do a git add dot because we've added several different files, or we've added one new file and we've changed in several. So we're going to do git commit -am windscreen, and then we're going to do git push origin episode 7. And now if we go over to GitHub, episode 7 just had a push. So we will go on ahead and merge this into main. And now we're all set. Main has our windscreen inside it. And we have episode 7 as a branch. All right, that wraps up today's adventure. Now next week, we're going to make our first special brick. This is going to be the special item that has a secret ability. Remember to like, subscribe, click the notification bell, and of course, stop by the blog. We'll see you around.